We are looking at systems of equations. So a system of equations means you have two variables, x and y, and then you have two or more equations. So in Algebra 1, we're only going to do two equations. So solutions to a system, graphically, is a point where the two lines intersect. Algebraically, the point that makes both equations true. So our solution is going to be an x-y pair. So we're going to do this a few different ways. So one of the ways we're going to do it is graphically. So on a graph where we graph it ourselves. And then we can also use our calculator to graph it, and we can use the calculate feature on the calculator. And then we can also look at the table of values. So that's why you have the three different pages. We're not doing notes on all three. It's basically instructions on it. So types of solutions. So if the two lines that you graph intersect, the point where they intersect will be your solution, x, y. It's one solution. If you graph two lines on a graph, but they never touch their parallel. Remember, systems, the solution is where they intersect. Parallel lines never intersect. So we'll have a no solution there. So you can write it 0 with a slash through it, or you can write out no solution. If your system is the same line, same exact line, one on top of the other, then you have infinitely many solutions because everywhere on the line is where they intersect because they're the same. So we're going to start with this example here. So we're going to start with y equals x minus 3. So in order to graph, we look at the b, negative 3. So we plot that on the y-axis. So go down to negative 3. And then your slope is your m. It's a number in front of x. There's nothing here. So the only thing that would be in front of x would be 1. But slope is rise over run, so it's 1 over 1. So start at the negative 3 and go up 1 over 1. Up 1 over 1. Up 1 over 1. And continue. Then go back to your y-intercept and go the complete opposite of up and right. Go down and left. Use your ruler to make a line. And we need to go ahead and name this line. I'm going to go ahead and write it out here. Y equals x minus 3. So that way I know which one's which. So I'm going to go to the next one. Y equals negative x minus 1. So we start with our b. B is negative 1. So we're going to start with negative 1. Plot your y-intercept. And our m, it says negative x. So it's going to be negative 1 over 1. So down 1, right 1. Down 1, right 1. Keep on going. Up 1, left 1. So always start at your y-intercept and then do your slope. Rise over run. Go ahead and draw your line, put arrows on it, and name it. You can name it on either side, either the top or bottom. I chose to name it on the bottom because there was more room. Okay, so we're looking for the solution to the system. Solution is the point of intersection. It's right here. So we need to write the coordinates to that point. So in order to write the coordinates, you walk before you climb. So start here. I'm going to go 1, -2. So my solution is 1, -2. So before we go to the next problem, I want to look at this one in the calculator so I can show y'all how we are using our notes from the purple page and the yellow page. Let's look at the yellow page first. So identifying solutions from a table says finding the solution of a system from a table. The point will show up in both tables if it is the solution. Some values for 2 linear equations are shown in the tables. What is the solution to the system of equations represented by these tables? So what it's saying is that point will show up on both sides of the table. So in a calculator, this is how it's going to look. So we're looking for where they are the same. So see y1 and y2, those are your 2 different equations. So it's saying the x value is -12, the y1 value is -6, but the y2 is -10. So then we look at the next one. The y's are not the same. The next one, they are. So this is how it shows up on the table. So for this one, the solution is -4, -2. The x value is -4, the y value is -2. So look at the next one. You're looking for where the y values are the same, and that'll be your solution written as an xy. So look at the first one, 0, 7. y1, y2 are 7. So those are the same. So our solution is 0, 7. So see on the table it gives it to you automatically. All right, the next one, we want where they're the same. Zero, -3. So on a table, it's pretty easy to find. Okay. The tables written like this are a little different. You're still looking for the x, y being the same. So look at your x and y here. Look at your x and y here. Where do they have a common point? 8, 6. So see how they both have 8, 6? So that's your solution. That's where they are both at the same location at the same time. Okay, look at that one to the left, the final one. Looking for where they're the exact same x and y on the table. 0, 6, exactly. Okay, so now you see on a table where it's found. So where it's found on the graph, where it's found on the table. So we are going to look at that right now in the calculator. So get out your calculator. I'm going to put the yellow sheet to the side. And we're going to do this system of equations. So go to y equals. Clear out what's in there. And for y1, we're going to put x minus 3. And for y2, put negative x minus 1. Got it in your y's? It's just the same thing. I just put this one in 1, this one into 2. Make sure you put a negative in front. The negative looks different from the minus. Pay attention to that. Okay, hit graph and look at it. It has 2 equations drawn, 2 lines drawn on the graph. So see how it looks the same? We know that the solution is 1, -2, right? So that looks about right. But what we can do is go to second graph for the table. Zoom 6. So now look at the table the way we have it written, like on here. So we're looking for where they're the exact same. So do y'all see the 1, -2 right here? It's right there. It's the same, which is the solution. All right, one other thing from this one. We're going to follow these steps. You'll probably remember these steps from solving equations. Y'all did this before. So it says, number 1, press y equals to display y equals editor. 2 and 3 push the equations. I'm not going to do those. 4, push graph. Then hit second calc 5. So second calc, and it comes to this calculate screen. It's right beside graph or trace. Number 5, and then hit enter 3 times. So our calculator will give us that system, the solution. Do y'all remember doing second calc, enter, enter, enter? Second calc 5, enter, enter, enter? No? Never did that. Okay, well, this is a way to find the intersection of those two lines, which it turns out to be the same, 1, -2. So look at 1, -2. So it actually names that. So the reason that we want to use the calculator, this is if it's a decimal, it's not 2 whole numbers. Because for the table, see how the x's are all whole numbers? So if it was a decimal, that's whenever the calculator becomes really, really helpful. All right, so let's go to the next one. We're going to do this one together. Y equals -1/3x plus 4. So in order to graph, we need our b. mx plus b is 4. Let's go ahead and graph it. And our slope is -1/3. Down 1/3. I can't go down and over 3 again, but I can go up and left. Okay, so go ahead and graph it. Make that line and name it. So I'm writing it over here on this side that y'all can't see. Here we go. Okay, the next one is y equals 2. So this is a Hoy problem because it doesn't have an m, x. So that means it's a horizontal line where y is 2. So go to your y-axis. Your b is 2. And it's a horizontal line. So to solve the system, we're looking for where they intersect. So it looks like right here, but it's off my grid. So this is where the calculator is going to be helpful. Let's think about, what do y'all think it is? 6, 2. So let's make sure. Let's put it into y equals. Clear out what's in there. I want everybody to practice putting it in the calculator. Remember, to get the negative 1/3, we can do alpha y equals negative 1/3 x plus 4 is y1. Y2 is just 2. Then hit graph. So it's right there, which looks the same as what we graphed. We can look at the table first and see if 6, 2 is on the table. And then we can do the intersect using the calculate button. So once you have it on here, let's look at the table. So second graph for the table, 6, 2, which it is. 6, 2 is on there. Y1 and Y2 both are 2. So that means that's my solution. So 6, 2 is right. All right, let's do the instructions on the purple page. Once we have it graphed, so we're already at step 4. Step 5 says press second, calc 5. Second, calc, which goes to calculate, number 5, and then 7, 6 through 11, it's telling you to press enter, 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 and enter. Intersection 6, 2. So see where that intersection is? It's the same thing that we found. So these are just different ways of finding it. One thing that you need to make sure whenever you hit graph, everybody look at that purple paper. Put on here, make sure you can see the intersection. If you can't see the intersection, then you use the zoom button. If you don't, then zoom out. So make sure you can see the intersection. If you don't, then zoom out. All right, let's go to the next one. Okay. The next one, y equals 3x. So let's graph it. So this is just an mx. There's no plus b. So b is 0. We're going to start out at 0. Then our slope is 3/1. Start at your y-intercept. Rise 1, 2, 3/1. Can't go up 3/1. So we leave it. Go down 3, left 1. I forgot to name this one up here. Y equals 2. So if you forgot to name it, make sure you go back and name that, because I forgot to do that. Okay, so I have this one graphed. The next one, b equals -4. -4. What's our slope? 3/1. What do you notice about that? They're the same slope. What happens when you have two lines that are graphed that have the same slope? They're parallel. They never touch. Exactly. So what kind of solution do we have on this then? Parallel lines. No solution, exactly. Whenever we look back over here, parallel lines mean no solution. 0 with slash through it, nothing. You don't put 0, you put a 0 with a slash, which means no solution. So on the calculator, it'll look the same. Let's go ahead and do the next one. X equals 3. So hoi vux. So this would be a vertical line. This is vux. A vertical line where x is 3. So go to the x-axis, go to 3. X equals 3 is a vertical line, undefined slope. So go ahead and draw that line. And name it. X equals 3. Okay, and then the next one is y equals 4. So this doesn't have an ilm-x either. So it's a hoi. Horizontal line where y is 4. So go to the y-axis. Here's our y-axis. Go to 4. So we have a horizontal and vertical line intersecting. So we need to write what the intersection is. So it's right here. So start at the origin. To find the location of this point, we would walk and then climb. So 3, 4. And this works for horizontal and vertical lines. Look at what x is. 3. What's the x value of our solution? 3. Y is 4. What's the y value of our solution? 4. So our calculator will not graph x equals 3. So we can't actually graph this. The only line that we can graph is y equals 4. We can't graph x equals 3. So we've just got to know where they intersect right there. So graphing by hand is going to be the way to go on that. All right, go ahead and go to the next one. Y equals negative 2 over 3x plus 2. So in order to graph, we need to graph our b and our m. So I'm going to graph 2, down 2 over 3. I can't go down 2 and over 3 again, so I'm going to go up 2, left 3. Okay, let's do the next one. This next one's written in standard form, so we've got to solve it. So we need to say y equals mx plus b, so move the x over to the other side by doing the opposite. Make sure you're following along with me. We've been doing this all year, solving for y. Divide by 3 all the way through. Negative 2 over 3. X is going to stay the same. 6 divided by 3. Plus 2. What do you notice about this one and this one? They're the same line. I feel like it was trying to trick y'all. So if they're the same line, what solution is it? Look back at the front. Infinitely many. Yep. So do I need to graph it again? No. I can just put a pink line right up next to it. They're the same exact line. All right, our last one. X plus y equals 3. We need to solve it. So I'm going to rewrite it over here. Rewrite it. Solve for y. So b is 3. M is negative 1 over 1. Down 1, right 1. Name it. Okay, so we've got to solve the other one for y. So subtract 8x on both sides. So on this one, it didn't require us to divide by a number in front of y. Neither did the last one, actually. So b is negative 4. M is negative 8 over 1. So we know that these aren't going to be the same line. They're different. So start it with negative 4. So a slope of negative 8 over 1. So that means down 8, right 1. But can we go down and right? Nope. Up and left. 1, 2, 3, 4, 5, 6, 7, 8 over 1. Oh, look at that. It goes exactly through a point. Okay, so y equals negative 8x minus 4. Go ahead and name it. All right, so then we just need to write what the solution is. So this point right here, negative 1. Yep. Negative 1, 4 is the solution. All right, you're going to glue these in the next pages, and your assignment is on Delta Math. We're going to have a few days to work on that assignment, but we are going to start it today.